Hello. Today we want to take a look at the energy that's in a spring and then compare that to the energy that is in a rock on a hill. So, one of those would be elastic energy, and one of those would be gravitational potential energy. So, I'm just going to go ahead and draw a spring on my board. This is a spring, it's being stretched out and it's being pulled off to the right. So I'm just going to draw an arrow on it so you can see it's being pulled off to the right, being stretched out. And you know that the elastic energy equals 1/2 times the force times the length on that spring. Okay. And I could also draw that this way. I could draw another spring going downwards, being pulled downwards. And if a spring is being pulled downwards, maybe I have pulling that spring down, maybe I have a 1 kilogram mass, okay, pulling that down. Now, that mass is not a force. And so I want to talk about this force just a little bit because this mass is creating a force, but a mass by itself is not a force. A force has some strange units and that I want you to see. Okay. A force has two kinds of units or two sets of units in it. You guys just watched a video about gravity on the moon, and you saw that gravity on the moon is different than gravity on the Earth. Okay. And so I want to think about this business of force here because I can pull out with a force, but there can also be a downwards force due to gravity. And what's causing that downwards force? The downwards force is being caused by two things. It's being caused by the 1 kilogram mass, but it's also being caused by how hard gravity can pull. Or, in other words, how much gravity could pull that kilogram mass down if the kilogram mass weren't stuck on the spring, right? It would fall towards the ground and it would accelerate. It would get going faster. Okay. And we write the amount of pull or the amount of acceleration that gravity can cause on that 1 kilogram mass. We write that this way. Okay. And that's how we get force. Force is made up of two things. It's made up by the pull of gravity, and it's also made up by the mass. Okay. And so in this case, uh, that 1 kilogram actually has a force equal to 10 kilogram meters per second every second. Okay, now those are some strange units. And we get sick of writing those strange units all the time. 10 kilogram meters per second every second. So we don't always say 10 kilogram meters per second every second. Instead, we write this: force equals 10 newtons. Okay. What I've just showed you is the units that a newton really is. Okay. A newton, which we've been talking about a force, is really made up of these units: kilogram, meter per second, every second. Okay. So I want you to remember that because when we start talking about the gravitational potential energy, the amount of potential energy in a rock that can fall down a hill, or the amount of potential energy in a concrete block on the energy vault, when we start talking about that, we want to understand what a newton of force is. Okay. So I want you to remember that a newton is a kilogram meter per second every second. All right. And that's going to help you out in just a little bit.